In the second part of the trilogy about the p-value, we go to the year 2016, to the headquarters of the American Statistical Association. They are discussing what is and what is not a p-value.
We did not have a group of people who all think the same way about it. And so after really a very long discussion, experts put together was then reviewed by our board of directors and adopted as a statement of the American Statistical Association. Everything that I need to know or I need to assume in order to go from my data to a p-value. And all of those things can be thought of as being in the statistical model, because if you change those things, you could end up with a different p-value.
Oye, mira, es que estoy estimando estos dos modelos y en este modelo esta variable es súper importante para explicar y en este otro no lo es. ¿Y por qué te asombra, no? Te asombra porque piensas que el contenido informativo es un concepto absoluto. El contenido informativo de X sobre Y no lo es. Es relativo.
Because there is so much flexibility in data analysis, theorizing, and then it's very simple. The distribution of p-values or any statistics is affected by any choice you make.
Therefore, the data may be incompatible with the model you have chosen, the variables, the data transformations, or the null hypothesis. There are many options.
When people incorrectly define p-values, probably the most common incorrect definition is saying that they are a measure of whether the finding happened by chance, which of course is not what p-values tell you.
Why do we then make this mistake? Look at the definition of the p-value in it. You're assuming that the null hypothesis is met. But the p-value is neither the probability that the null is true, nor that what you found is due to chance, because you're already imposing it in the calculation of the p-value itself. It's a somewhat peculiar circular reasoning, don't you think?
But to me, the third principle is the most important thing, and that is that that just because a p-value is less than 0.05 or something else is not a sufficient reason to jump to a conclusion.
P-value can be useful. I don't think that we should throw them away, but we need to stop misusing them and stop giving them, giving it more power than it has. It can't tell us whether it's correct. It should not be the measure of whether something is a good result or not.
Why there should be any substantive difference between a value of 0.049 for p and a value of 0.051 for p.
The 0.05 is like a natural law, huh? So people don't really question, people I'm working with don't really question the usefulness of 0.05, although it was never, I'm not aware that it was ever shown, that it's formally shown that this is a good or optimal choice.
If I'm looking at your study and and you are kind enough and open enough to provide your data, which oftentimes obviously doesn't happen, but let's suppose that it did. You've provided all your data, but I still can't figure out how you got the p-value that you got.
Meaning, if we only show the result that the p-value we desire gives us, we're doing bad data mining, the kind that seeks, by manipulating the data, a specific result and doesn't show how it arrived at this. It doesn't reveal which data it has discarded or what deliberate choices it has not made.
There's a big pressure to publish, there's a big pressure to publish significant results. This is a problem of the journals, it's a problem of reviewers. There's no surprise that researchers really use significance testing, use p-values, use significance to try to get published.
In the COVID-19 situation, there were some drugs. These drugs are now being used, but there were some drugs at the time that were being studied.
In this study, they arrive at this confidence interval from -14 to 2, which represents the possible effects on patient mortality, stating that there is no effect on mortality just because 0 is within the interval is, at first glance, a rather questionable scientific exercise. What other hypotheses are we rejecting? What medical and human costs would they entail?
But also could decrease mortality by a considerable bit. The point is that we should always be looking at those effect sizes, the confidence intervals, or other ways to think about effect, and not just stop with statistical significance.
Si el p-valor lo que intenta es reflejar la incertidumbre que hay o que generan los datos, yo p-valor versus intervalo de confianza, siempre. Y luego tú decides la confianza que le quieres poner, porque estamos no sé por qué atados al 5%.
El contraste de hipótesis es ponerte los ojos así y mirar solo a este punto. Y de nuevo tienes toda una evidencia muestral importantísima y de todas las hipótesis que podrías considerar, solo me estás mirando este punto y todo lo demás es una información que no me vas a dar.
Dichotomization, of results into significant and not significant results. This is clearly harmful, I think. It doesn't convey very much information. I don't think it's very critical.
Don't expect that there's just going to be a magic number that's going to tell you whether, something is true or not true.